Hi, this is Ajay Anand and welcome to science classes from excelup.com. In this lesson, you will be learning about acid and base. You will learn about reactions of acids and bases with metals, carbonates and bicarbonates. You will learn about neutralization reaction, that is the reaction between an acid and a base. Then you will learn how do acids and bases behave in aqueous solution. You will also learn about the pH scale and about acid-base indicators. What is an acid? Acid is a substance which has a sour taste and it turns blue litmus to red. There are two types of acids. One is called organic acid and another is called mineral acid. Organic acids are generally obtained from natural sources and they are weak acids, while mineral acids, they are usually synthesized in laboratory, and mineral acids are generally strong acids. How does an acid react with metals? When an acid reacts with a metal, salt is formed and hydrogen gas is evolved. In this setup, there is a test tube and there is a pan. The test tube is filled with sulphuric acid and some zinc granules, they are added to sulphuric acid. So within a few seconds, you can observe effervescence, bubbles, they start coming out from this mixture, and the gas which is evolved, it is passed through a tube and it is collected in this pan which is already filled with water. So bubbles of gases can be seen emerging from this water. This equation can be written as Zn plus H2SO4 is equal to ZnSO4 plus H2. How do we know that the gas is hydrogen gas? So for this, you need to do a confirmatory test. Bring a burning candle or a burning splinter near the bubbles, and if it burns with a pop sound, it confirms that hydrogen gas has been evolved. Some other examples of this reaction are when zinc reacts with hydrochloric acid, zinc chloride is formed. So the equation is Zn plus 2HCl is equal to ZnCl2 plus H2. When sodium reacts with hydrochloric acid, then sodium chloride is formed. The equation is 2Na plus 2HCl is equal to 2NaCl plus H2. When iron reacts with hydrochloric acid, then iron chloride is formed. So the equation is Fe plus 2HCl is equal to FeCl2 plus H2. Now, what about acids reaction with metal carbonate? So when metal carbonate reacts with acid, once again salt is formed along with carbon dioxide and water. In this setup, there is a test tube in which hydrochloric acid has been taken and sodium carbonate has been added to hydrochloric acid. Once the reaction happens, a gas is evolved. Now, this gas is passed through a test tube which contains a solution of slaked lime, that is calcium hydroxide. So the equation is Na2CO3, that is sodium carbonate, plus 2HCl is equal to 2NaCl plus CO2 plus H2O. So for confirmation of carbon dioxide, this gas has been passed to a solution of slaked lime. So the liquid turns to milky white or somewhat cloudish, whitish appearance, and this happens because of formation of calcium carbonate. So once the mixture becomes cloudy, it confirms that carbon dioxide gas has been evolved. Some other examples of this reaction are reaction of magnesium carbonate with hydrochloric acid, which gives magnesium chloride. The equation is MgCO3 plus 2HCl is equal to MgCl2 plus CO2 plus H2O. Then reaction of calcium carbonate with hydrochloric acid gives calcium chloride. The equation is CaCO3 plus 2HCl is equal to CaCl2 plus CO2 plus H2O. When calcium carbonate reacts with sulfuric acid, the reaction gives calcium sulfate. The equation is CaCO3 plus H2SO4 is equal to CaSO4 plus CO2 plus H2O. When acid reacts with hydrogen carbonate, the reaction is same as the reaction with carbonate. Hydrogen carbonate is also called bicarbonate. So acid plus bicarbonate is equal to salt plus CO2 plus water. One example is the reaction of sodium bicarbonate with hydrochloric acid, that gives sodium chloride. So NaHCO3 plus HCl is equal to NaCl plus CO2 plus H2O. Then 2NaHCO3 is plus H2SO4, that is sulfuric acid. It gives sodium sulfate, Na2SO4 plus 2CO2 plus 2H2O. In the case of test for carbon dioxide, when you use solution of slaked lime, this reaction takes place. This is calcium hydroxide, slaked lime. CaOH whole 2 plus CO2 is equal to CaCO3, calcium carbonate plus water. And the liquid, it turns to whitish because of the formation of calcium carbonate. Another significance of this reaction, that is the reaction between acid and carbonates or bicarbonates, is the effect of acid rain on monuments and buildings. What happens? That monuments are made of stone or marble. So when acid rain falls on the monuments, it corrodes the structure of the monument. So to understand this, let us take the example of the Taj Mahal. Taj Mahal is made of marble, and marble is nothing but calcium carbonate. So what happens when calcium carbonate, it will react with acid, a salt is formed, carbon dioxide gas is evolved, and water is formed. So in this process, the marble, it gets corroded, and that is why acid rain harms the historic monuments and buildings. Another significance is the use of acid and carbonate or bicarbonate in fire extinguisher. In fire extinguishers, acid is kept in a separate chamber, carbonate or bicarbonate is kept in another chamber. When the trigger is released, then acid mixes with carbonate or bicarbonate and a reaction is set up which releases carbon dioxide gas. And you must have read in your previous classes that carbon dioxide gas works as a fire retardant, and that is how fire extinguisher works in helping in putting off the fire. Base. Base is a substance which has a bitter taste and it turns red litmus to blue. There are two types of base. One is called water soluble and another is called insoluble in water. The ionic salts of alkali and alkaline earth metals are water soluble, and water soluble bases, they are also known as alkali. Some examples are NaOH, MgOH and CaOH whole 2. These are, that is alkali they are strong bases. When a base reacts with a metal, then salt is formed and hydrogen gas is formed. One example is reaction of sodium hydroxide with zinc. It gives sodium zincoate. The equation is 2NaOH plus Zn is equal to Na2ZnO plus H2. In this reaction, sodium hydroxide is reacting with aluminium. So it gives sodium aluminate. The equation is 2NaOH plus 2Al plus 2H2O is equal to 2NaAlO2 plus 2H2. When a base reacts with a non-metal oxide, then salt and water are formed. Non-metal oxides, they are acidic in nature. So these are kind of neutralization reaction also, about which you will learn in the later section. The example is reaction of sodium hydroxide with carbon dioxide. The equation is 2NaOH plus CO2 is equal to Na2CO3, that is sodium carbonate plus H2O. When calcium hydroxide reacts with calcium oxide, carbon dioxide, it gives calcium carbonate. The equation is CaOH whole 2 plus CO2 is equal to CaCO3 plus H2O. Neutralization reaction, that is the reaction between acid and a base. When an acid reacts with a base, both of them, they neutralize each other, and in the process salt is formed and water is formed. So let us take one example, that is the reaction between HCl, hydrochloric acid, and sodium hydroxide. So this is an acid and this is a base. So what happens, the H plus ion from the acid and OH minus ion from the base, they combine to form water, and the negative ion from the acid and positive ion from the base, they combine to give a salt. So sodium ion is combining with chloride ion to give sodium chloride. Another example is of reaction between sulfuric acid and sodium hydroxide. This gives sodium sulfate. So H2SO4 plus 2NaOH is equal to Na2SO4 plus 2H2O. Nitric acid reacts with sodium hydroxide to give sodium nitrate. The equation is HNO3 plus NaOH is equal to NaNO3 plus H2O. What happens when acid reacts with a metal oxide? Metal oxide is basic in nature. So this will be once again neutralization reaction, and this reaction will give salt and water. The examples are hydrochloric acid's reaction with calcium oxide, it gives calcium chloride. The equation is 2HCl plus CaO is equal to CaCl2 plus H2O. When sulfuric acid reacts with zinc oxide, we get zinc sulfate. The equation is H2SO4 plus ZnO is equal to ZnSO4 plus H2O. When aluminium oxide reacts with hydrochloric acid, we get aluminium chloride. The equation is Al2O3 plus 6HCl is equal to 2AlCl3 plus 3H2O. What happens when acid or base is dissolved in water, or how do acids and bases behave in aqueous solution? When an acid is dissolved in water, it gives hydrogen ion, that is H plus ion. Now this hydrogen ion is not stable, so it combines with one molecule of water, that is H2O, to form H3O plus ion, and this is called hydronium ion. Okay, so for example, when HCl is dissolved in water, it gives H plus and Cl minus ion. When H2SO4 is dissolved in water, it gives H plus and SO4 double minus ion. When a base is dissolved in water, it gives the metallic ion, that is M plus, M stands for metal, and OH minus ion. This is called hydroxide ion. So for example, NaOH, Na plus and OH minus ions are obtained when NaOH dissolved in water. So on this basis, it will be much easier to understand the neutralization reaction. So here HX, it stands for acid, and MOH is stands for base. Okay, so the metal and the negative ion from acid, they combine to give a salt, MX, and H and OH, they combine to give water, H2O or HOH, that is water. So acid plus base is equal to salt plus water. pH scale. pH scale is the scale which quantifies hydrogen ion concentration in a solution, and the range of pH scale is from 0 to 14. When concentration of H plus ion is more than the concentration of OH minus ion, the solution is acidic and its pH is less than 7. when the concentration of H plus ion is equal to the concentration of OH minus ion, the solution is neutral and its pH is equal to 7. When the concentration of H plus ion is less than that of OH minus ion, then the solution is basic and its pH is more than 7. So for neutral solution, that is, say for example distilled water, the pH will be 7. For acidic solution, the pH will be less than 7, and for basic solution, the pH will be more than 7. So for acidic solution, pH will be anything from 0 to 6 or maybe 6.9. So if the pH is 0, the acid is very strong, and if pH is 6, the acid is weak. Similarly, for a base, if pH is 8, it's a weak base, but if pH is 14, it's a strong base. So that is how the pH scale also gives the value of relative strength of the acid and base. Indicators. Indicators are those substances which change color or smell in presence of acid or base, and on that basis we can recognize if a given sample is acidic or basic. So many indicators are used. Litmus is the most common indicator used in laboratories. Litmus is made from extract of lichen, and litmus is available as red litmus paper and blue litmus paper. So red litmus paper shows no change in presence of acid, but red litmus paper turns to blue in presence of base. Blue litmus paper shows no change in presence of base, but it turns to red in presence of acid. Other common indicators are phenolphthalein. It is a colorless solution and it remains colorless in acidic solution, but phenolphthalein turns into pink in basic solution. Methyl orange has orange color. It turns to red in acidic solution and turns to yellow in basic solution. Now these indicators, they can just tell whether the given solution is acidic or basic or neutral, but they are unable to tell the relative strength of the given solution. So for this we use universal indicator, which is a mixture of methyl orange and many other substances. The universal indicator gives a range of color, a wide range of colors, and based on that range we can be more accurate about the relative strength of the given sample. Okay, so we can know, okay, this acid is weak and this is strong, or this is a strong base and this is a weak base. So I talked about the definition of acid, then I talked about chemical reactions of acids and bases, reactions with metal, reactions with carbonates, reaction with bicarbonates. Then I talked about the neutralization reaction, that is the reaction between acid and base. Then I talked about the pH scale, and I talked about acid base indicator. That's all for this lesson. Thank you.